Hello everyone, welcome to today's video. Today we are going to discuss the last part of electrolysis, that is electrolytic refining and electroplating. So let us begin the video without any delay. If you have not watched yet the previous two videos, please go to the channel and do watch it. So let us begin. Electroplating is the first topic we are going to hold. Electroplating. By the term you have already read before also, electroplating. That means to plate something with the help of electricity. Yes, you are correct. Plating. To plate something with electricity. What is this something? Something is a thin sheet of metal on another metallic article. Clear? On another metallic article with the help of electricity. That is electroplating. Clear? Generally we use gold, silver, nickel. These are the things we use to plate. Chromium is also there, nickel is also there. Okay. Why do we electroplate? First thing is to prevent rusting and all that resistance. Second one is decoration. We need so much decoration. So one is protection from rusting, corrosion. One is our decoration. Two reasons rather why we do electroplating. Okay. Now we will study electroplating with two things, that is silver and nickel. So we are going to individually study electroplating of silver and electroplating of nickel. Okay. Before we begin, some things I need to say about electroplating. Whenever you are electroplating something, the element, the article which will electroplate always has to be at the cathode. Cathode, what will be at the cathode? Article to be electroplated. Article to be electroplated. If the name is mentioned, please write the name. Cannot write, suppose is mentioned electroplating an iron spoon with silver. Then cathode is iron spoon. Cannot write this article to be electroplated. What is the article given in the question? To write that only. Okay. Next is anode. What has to be at the anode? Obviously the substance which you are trying to electroplate with. Right? Suppose you are electroplating an iron spoon with silver. Then you write no silver only. Then where will it come from? So the anode has to be the metal which you want to electroplate with. Clear? If it is silver, if it is nickel, chromium, whatever it is, it has to be there. Clear? Understood? And electrolyte also has to be the substance that contains that metal ion. Next important thing is, you cannot use an alternating current. It will be a very non-uniform deposition. Okay. Direct current has to be used. Okay. Next is, you cannot randomly pass a very high current and suddenly you stop the current. That means for a low time, you pass a high current, that is not going to be efficient. Why? Because you pass a lot of under current, non-uniform deposition will happen. Suppose deposition will occur at one position particularly, other position is not deposited at all. That will happen. But if you pass low current for a longer period of time, then deposition is going to be efficient. So low current for a longer period of time is preferred for electroplating. Okay. Clear? Now let us move on to electroplating with silver. Electroplating with silver. For electroplating with silver, the first thing we need to know is, let us take cathode, iron spoon. Okay, let us take cathode is iron spoon. Done. Anode will be Mr. Silver. That is pure. Okay. So anode is silver. Right. Now comes the question, what electrolyte should be used? Which electrolyte should be used? There are so many electrolytes available. Which one to use? Specifically it has been mentioned which electrolyte to use. There is sodium argentocyanide or potassium argentocyanide electrolyte. Na, sodium or potassium, formula remains same for both. Okay, NaAg, Cn whole 2 or KAg Cn whole 2. Clear? Electrolyte has to be sodium argentocyanide or potassium argentocyanide. Now your question will be, why are we not using this? AgNO3 will dissociate very fast. Okay, reaction will be very fast. Non-uniform deposition again will take place. We do not want that. So we will be doing with sodium argentocyanide. Clear? Okay. Now dissociation reactions, we have to see. There is only one dissociation reaction is there. So I am not writing dissociation reaction. Okay, I am direct going to cathode reaction and anode reaction. Okay, cathode. What will happen at the cathode? V1 deposition. So that has to be deposited. That means some metal has to be deposited. So we are concerned with only silver, right? So silver 2 positive ions will gain 2 positive ions and form the silver metal, right? Silver 2 positive ions will gain 2 electrons and form silver. Okay, here let us consider one valency only. Okay, because sodium argentocyanide is showing one silver valency. Okay, let us consider one valency. Clear? So Ag plus electron will form silver metal. This silver metal is now getting deposited on the iron spoon that we have already taken before, right? Okay, what is happening at the anode? What is exactly happening at the anode? Opposite of this. Clear? So observation, cathode size increases, anode size decreases. Simple. Clear? Observation, cathode size increases, anode size decreases. Understood? Why it is happening? Because we are depositing the silver metal on the spoon that we have taken, right? So anode size will decrease because this again is being used up over here. Clear? Okay. Now thickness of coating will be depending on, as I have already told, how much time you are passing the current for. Clear? Okay. Acha. Next is, if we replace this with a nickel sulfate, then we will use electrolyte as nickel sulfate. Okay, I am writing here. So electrolyte will become nickel sulfate. Clear? So as a result, here instead of this, you are going to write nickel 2 positive, 2 electron, nickel metal. Here it will be nickel metal minus 2 electron forming nickel 2 positive. Clear? Again observation remains the same. Observation again remains the same. Clear? Okay. Now one question might come, anode has to be replaced periodically. Why? Reason is simple, very much visible. Anode has to be replaced periodically because anode diminishing in size. Clear? Anode gets used up, anode is diminishing in size, so it has to be replaced periodically for the reaction to continue. Clear? Understood? So nickel sulfate is the electrolyte we are using for electroplating with nickel. Okay? Next, electro-refining of copper. Electro-refining of copper. Clear? First let us learn what is electrolytic refining, or that is also called electro-refining. Acha, what is electro-refining? Electro-refining means the process of metals containing impurities being separated electrolytically. Clear? That is why we are saying electro. So the process of the metals being separated from impurities to obtain a pure metal is called electrolytic refining. Clear? Clear? So a metal always has to be pure, that is never written anywhere. So you have to first purify it. For purification we use electrolytic refining. We are going to study electrolytic refining of copper only. Electrolytic refining of copper, the solution that we use is CuSO4 plus H2SO4. Clear? CuSO4 plus H2SO4. Achha. Here the cathode is pure, anode is impure. Clear? Cathode is pure and anode is impure. Clear? Cathode is pure and anode is impure. technique to remember is m is there. Here m plus 1 n is there, here no n is only there. Clear? Here m plus 1 n is there, but here nothing. No n, no n, nothing is there. So this cannot be impure. Clear? Impure slabs of Cu and pure thin strip of Cu. This impure block, whatever will be the red mud, that is Fe2O3, sand, silica, whatever it will be settled below. Observation remains same, anode size will decrease as a result, this size will go on increasing. So if we do not take it as thin before, your size will increase and maybe something else will happen. Clear? So this size is taken more so that the red mud decomposes and not decomposes, it settles down below, and this becomes thing that we want, pure. Right? So we have taken thin pure strip. Okay. Acha. Cathode reaction, anode reaction remains same as we did in first part where we use copper electrodes. You remember the reaction, Cu plus 2 electron from Cu and Cu minus electron from Cu2 plus, same thing reaction going on over here. Clear? So as a result, from here size will start on decreasing and increase size over here. So the red mud will settle down. The red mud will settle down and the copper that is deposited over here, it will be 99.9% pure. Okay. Red mud you can say, or anode mud. Better you say anode mud. Red mud is said some alumina. Anyway, so this is anode mud. Clear? Better you say anode mud. So anode mud is whatever impurity is present will be settling down. That is called anode mud. Clear? Anode mud. So as a result, whatever you get, copper, that is 99.9% pure. Understood or not understood? Understood? Okay. So that is all that you had in your syllabus from electrolysis. In the next video, we will be beginning with the next chapter, that is metallurgy. Okay? There are also a lot of directions are there. So we'll see you in the next video. Thank you.